Hello and good evening, everyone. Thank you for joining us and welcome once again to another Geeks by the Fireside conversation. So these conversations are hosted by GH Scientific. They are recorded, and so we will share the tidied up recording on YouTube and across our socials at the end of the event. And so our guest this evening is joining us from KNUST, I believe, if he hasn't moved on since the last time I got the profile. He's joining us from KNUST in Kumasi, not just as a friend and partner of GH Scientific, but also, another STEM geek. We call our community member STEM geeks. We proudly geek out about STEM conversations. We have other partnerships that have been supporting, the experience of STEM events nationwide, Tamale, Cape Coast. We don't have a partnership in the Volta region yet, and quite a few other regions. So we still have a long way to go, but journey of 1,000 miles always starts with the first step. So this evening we have a special guest with us. He's in the person of Cyril Boateng. And I won't give too much away. I will give a brief profile and I will let Cyril introduce himself again to fill in the gaps that are missing. And we had a little conversation earlier today to align on what we were going to talk about this evening. But as I said to Cyril, conversations are most enjoyable and most authentic when they are not scripted. And so anything we're going to talk about this evening has not been scripted. We are free flowing. So do put your questions in the chat as we go along. So Cyril is a senior lecturer and researcher in the Department of Physics at KNUST. That's the Kwame Nkrumah University of Science and Technology, Ghana, for those listening to us online. He focuses on the application of machine learning in geophysics and leverages geophysical methods to support the achievement of the SDGs being the Sustainable Development Goals. And so most of the conversations we're going to have this evening is really around what has led Cyril into this not very popular field. From where I come from, I'm not sure if it's very popular in the KNUST space, because I know there are lots of geeks at KNUST. And if I did do university in Ghana, it would have been my first choice. And so I know Cyril has been involved in some really interesting projects. So the theme that we had put out was, AI, archaeology, and physics. And to really understand how he's merging all of these in his research areas. So Cyril, our conversation has officially started, right? I'm curious as well, because we know AI is now a buzzword. It's almost as if there will be applications of AI in almost all sectors, right?
Yeah.
One information I did get from Tom is that you did your PhD in China and you lecture at KNUST. And so I don't know much either, and we haven't interacted much until today. So first of all, please educate me. What is geophysics?
So geophysics is basically using physics and then mathematics, computer science to study the earth. So for, let's say, if you want to understand what is happening in the earth, you need to find a way of studying the properties of the earth. So just like you say, I'm measuring, I'm getting different materials and trying to find out what maybe magnetic properties they have or electrical properties they have. So geophysicists do that for the earth. And that is quite useful because then we can use that to look beneath the earth. For instance, if you want to find gold, if you want to find oil and gas resources, if you want to find water, or in my case, if you want to work with archaeology and discover whether there's been a community here 100 years ago and what kind of life they had. So geophysics is basically just learning about the earth. We could also add other planets, of course. So it could extend to studying other planets or other bodies in the universe. But basically, it's about studying planetary bodies, especially focused on the Earth, using physics tools. So I hope that makes sense.
Okay, using physics.
Emphasis on physics.
Physics, there's a bit of mathematics. How long has this? Did you do geophysics at KNUST, or you specialize as part of
Yes.
your PhD?
Okay, so interesting. So I actually started with chemical engineering for my
Okay.
first degree in KNUST. And then subsequently for my master's, then I switched to geophysics. I've always been interested in physics, but if anyone who knows how Ghana works, is mostly you don't get the courses you want in the university. But basically, you are not. I didn't really know that there was a program for geophysics, for instance, in KNUST. But then after my first degree, you now have the choice to pick what you are really interested in. So I picked. I did geophysics for a master's, and then I went to China for a PhD in solid earth physics, which is still geophysics. So, but that's focused on the earth. So
Normally, okay, when we're picking programs or courses, right? I'd like to think most people want to know their job prospects, right? We know you're a lecturer or a senior lecturer now at KNUST.
yeah.
What are the other job areas for geophysicists?
Okay, so primarily for earth physics, earth geophysicists, those who are focused on earth physics, then you are primarily going to focus on exploration. So exploration, like I mentioned, for gold. If for of course the illegal miners don't really care, but for established companies like Anglo Gold, before they would ever go drill or set up a mine, they would have done some exploration. They would have used magnetic um, magnetic methods, electrical methods to study the earth and find out whether there's a gold seam where they want to mine. Um, for instance, if you are looking for oil and gas, Ghana's oil is offshore, buried kilometers under the ground. So how do you know there's oil at a particular place? You need to. I have this running joke with my students that we are sort of like the um, how do you call it, Mr. X-rays of the earth. So we have this superpower for geophysicists to be able to X-ray and see what is in the earth. And once we have that, we can tell you where the resources are. So for oil and gas, same. For groundwater, almost everybody in Ghana is drilling for water these days in their homes. Some people drill and don't find anything. The right way would have been to have a geophysicist then explore and tell you there's groundwater where you are drilling before you even drill. Or then for the application in archaeology, like I was saying, you want to find out if there's a community here before the archaeology starts even excavating for material relics. A geophysicist can then do that for you because we can tell you if there's a foreign material in the ground different from the actual soil or the subsurface here.
Okay. Now,
So the prospects are good.
yes,
Yeah.
I'm getting a better picture of the geophysics industry now, actually. So pretty much mining, as you're saying, the offshore drilling, anything that requires you to access the earth for natural resources,
Yes.
that comes under geophysics, right? So it will be a popular program because, of course, Ghana is rich in natural resources, and then the oil came in as an additional bonus. Except, okay,
Yeah. Yes.
so naturally, the conversation is going to not have to miss out Galamsey because it's one of the hot areas in this recent times because of the illegal mining. So, not to put you on the spot, and feel free to decline if you don't want to comment. It's not a political question, but from your knowledge of the earth resources, what do you think can be done to almost revive the natural resources we have damaged? Is it possible?
Over time, yes. I know from the work being done with the soil scientists, you can actually do remediation and take out some of those heavy metals out of the soil. Usually, where I start from for the geophysics side is that we possibly don't even know the extent of the damage we've caused now, which is a huge problem. So let me take an example. Groundwater seeps through the ground and takes years to move from one level of the subsurface layer to another. Now, the moment you contaminate groundwater, it means it's going to go through the soil and then go join some bigger reservoir of water somewhere else. The first step for me, from my side, would have been that we should be able to map the extent of the contamination we have, which is something geophysics can do. Well, we've not done that yet. If we stop the damage now, and do the remediation and all that. Yeah, maybe give it a couple of years, we can do that. China was able to do that when they started their industrialization. Like they were dumping poisonous materials everywhere. But in most of those places now, they've done remediation and they've been able to reclaim the land. So we can't do that. And there are other examples with, for instance, with mining companies. All the big mining companies have tailings dams where they store the water they use for processing, right? And once they store, after some time, the heavy metals settle in the pond. And once they are done, they do reclaim those ponds. Once they are done using that particular place, they have very good programs where they reclaim the land using sometimes local plants, sometimes but materials, plants that have been studied, and we know that they have the capability of taking these materials out of the ground. So it is possible. It's just that we need to stop the contamination now, um, and that's where the political side comes in. So if you can do that,
Okay.
then we can start reclaiming.
When I hear we need to restore our land, it's you're telling me to go on a tree planting exercise, but there's more to it than that.
Oh, no. There's much more to it than, because you need to know where the distribution of, let's say, so a simple example, you need to know where the contamination is, the extent of contamination. Then you need to know if the plants that you are going to put there can actually do the remediation for you, right? And then how long would it take? And then maybe you have to take the first set of trees out and maybe plant another one, and possibly check whether you've actually taken the material, the hazardous metals out of the ground and all that. So there's much more to it than that. Yes.
Okay. There's a question in the chat which says, how different are geophysics, geology, and geomatics?
That's a good question. So geologists would work by observation. So a geologist will identify a rock and tell you these are the rocks here, and then use that to build a model. So once they know the arrangement of the rocks, they can tell you the history of the earth as a particular place. Geomatic is more of surveying. So they use surveying tools to be able to tell you a particular position of a body, or a particular feature you are interested in. Now for geophysics, we use physics and mathematical models to study the earth. So we may not necessarily need, of course, we use geology as a, how do you call it, as a validation of our tools. But like I said, once I come here and I say, I want to know whether there's groundwater in the ground here, how do I know that? The groundwater is possibly maybe 20 meters to 100 meters below the ground. I am on the surface of the earth. I can't see into the earth. So I need to know that without, and if I say I want to drill, drilling costs a lot of money. Good example, maybe even groundwater is not drilling for oil and gas in Ghana offshore could probably cost you between 30 million to 50 million for a single well, borehole. So before you go there, you need to know whether there's oil there. Now, how do I look beneath the ocean and beneath the ground below the ocean that there's oil somewhere? So there should be a way I can do that. And that's where we deploy our tools. So for oil and gas, for instance, we deploy a tool called the seismic method, which is essentially an acoustic method. You are generating sound waves, vibration. So once you generate these waves, they go into the ground. And just like we learned in secondary school, waves are reflected, refracted, they are diffracted. So once those things happen to the waves, they come back up to the surface. If I have a set of sensors on top of the surface, then I can take back these waves. And once I measure the waves I've gotten back, then the question is, how were they modified? Because I know the initial waves I sent into the ground. So if I can compare what I've gotten after the interaction with the subsurface and what I initially sent in, I can then use that to understand what layers are in the earth, right? So in geophysics in this case is not really, may not be going into the ground to observe the rocks, but because of the physics tool, it can tell you the properties of the rocks in the subsurface. And that can then let you know that, oh, there's a reservoir of oil and gas in here. So now go drill for that oil and gas. So that's the difference.
Okay, great. Hopefully that answers the question. Do keep bringing your questions through the chat. We're keeping an eye on it. I'm going to move away from geophysics slightly to archaeology now. Again, from my novice point of view, and like Ghanaians do archaeology. So, and so when I think archaeology, I'm thinking fossils, I'm thinking the dinosaurs, I'm thinking the ancient remains that tell us the evolution of the human life form that we have today. That is what my textbooks told me, generally around archaeology. But I know you've done some interesting work and research where I suppose you've used archaeological studies to give us information about slave trade or some of the things that may or may not have happened during that era. So I don't know much about it. So you're able to tell us a bit more about that work and some of the discoveries or information that you've gathered through that archaeological studies.
So I hope the University of Ghana doesn't get angry with you because they have had an archaeology and heritage studies department for like forever.
Really?
So
Did you find
yes,
dinosaurs in
so
Ghana?
yeah, so I think it's one of the oldest archaeology departments in Africa. They've actually done a lot of work in studying archaeology. So so that the what we have brought on board is so let me take it from this side. For instance, we all watch these documentaries on TV, we read about archaeology, but the focus is always on ancient Rome, Greece, some other sophisticated or some other civilization. Now, look at it from this point of view. Africa is supposed to be the place everybody originated from, which means we would have had the longest history in terms of humans for the whole earth, right? And then but interestingly, anytime you hear archaeology, like you said, it's more of ancient Rome, Greece. So there must be a lot of missing pieces that we've not really tackled, which is what I think we should do in Africa, because then there's that large piece of information for the longest period of human existence. We are missing those pieces, right? So that's one of the things we thought we could work on with the geophysics. Our specific focus on slavery was because again, you realize that when you come to Ghana, the slave trade story is usually focused on the castles. And I, one of the things I found weird about that was I still think even the castles are actually a symbol of oppression. So why do we focus on the castles when, if let's say slaves were going to be taken from Salaga or from Togo or from Benin and moved to a castle on the shores of Ghana, they would have traversed different communities, they would have interacted with materials, they would have cooked, they would have lived in a community, which means there should be a lot of evidence of that as well. And that will probably tell us the kind of people who were taken, how they lived, how they interacted, how they resisted. Yes. And there are pieces of that kind of information around, but I didn't think we had a full focus on finding those sites. So that's where the archaeology story came in. So I think in 2022, we won a grant to be able to do that through a field camp, training students in geophysics and then looking for places where the stories are hidden, are not really that clear. One of the places we focused on was the Volta region, um, which is the southeastern part of the Volta region. So I'm from the Volta region, but some of the places we went to, I didn't know had any relation to slavery, for instance. So we went to Aflao, we went to Keta, yes, and let me give you an example of yes, in Denu, for instance. So here we had a family that had actually played a prominent role in the slave trade, right? And then the family still lives where they've lived for 200, 300 years. So on our reconnaissance surveys, one of the family members actually then informed us that, okay, we have an oral account in our family that says during the time the slave trade was abolished, because our forefathers or our great great grandparents were slave traders, they had to hurriedly bury the tools they used for the slave trade. And we know it's somewhere in our compound because they had this huge compound, but we don't know exactly where it is. So if you can help us figure out where it is, and that's this somewhere that geophysics can feature prominently, because then we don't know where the thing is, but we know it's another ground. So if we can use our tools, and for the slave trade, the tools we are looking for are shackles, chains, which are very different from how the F materials are. So they should really pop up on any studies that we do. So we actually ran surveys in the whole courtyard, and we were able to identify the places that we think that the things were buried. Unfortunately, we've not been able to excavate them yet. It's another story. But we're actually able to locate where they are. Yes. The most recent one we did was actually go back to a castle which was destroyed. So, and that is in Otiam. That was done last year. So Otiam, that's the hometown of, I think, our former Professor Atamios.
Mm-hmm.
So there's a fort there that has been totally destroyed. That one, so I didn't know. And then we wanted to find out the historical connection between the slave trade and that fort. And it's actually not on the list of the forts and castles in Ghana. So we located the site, we ran a couple of surveys. And one of the interesting things we found is that for the first time in Ghana, we're able to find musket balls. So musket balls from what the Europeans use. Now, in most places in Ghana, you would find how do you call them? Cannonballs. If you go to the castles, you see cannonballs here. But musket balls have never been found on a site in Ghana. But with the geophysics, we were able to identify 2 locations for excavation. And once we excavated, we found 4 pieces of musket balls on this side. We also found pipes from the Europeans. We also found hinges from the doors that were there. You could see the different makeup of those. And then we also found that's the interesting part. We found materials from the habitation of locals because we found what the archaeologists call quens. Quens are like materials from local, maybe native inhabitants, like grinding stones and that kind of thing. And we found those on the site as well. So you could easily then draw the connection of the fort being connecting both Europeans and Africans. The exact nature of that connection may not be too clear, but we do know that there were Africans within the vicinity of the fort who were using local materials. And then there were also Europeans with the fact that we find musket balls also tells you there's some violent connection to the fort as well. So those are some of the results. Yes.
Okay, so
I've been rambling on this one.
No, it's really interesting because as you're speaking, I'm thinking. So I guess because the question is always and so what, right? But I suppose in the case of archaeology, it's history and documentation and storytelling, and almost
yes,
separating the facts from the myths. What was it? And so what? Yes.
All right. So let me give you a typical example. So at the Ochiam site, we had combined drones with geophysics to be able to understand the layout of the place. Now, we had an artistic impression of what the fort should have looked like, and the artistic impression showed like 4 bastions at the edges of the fort. Those round things usually are the corners of castles, right? But then using the drones to survey the site, and then physical observations show that we couldn't have had 4 bastions because the amount of rubble. So for this fort, it was totally destroyed. Unlike there are forts and castles you go to in Ghana which are suffering from natural decay in terms of plants going or walls falling. But in this case, the fort was like shattered into smithereens. You could just find the rocks, all the building blocks scattered all over, right? So at least you know that this is related to maybe a violent kind of destruction of the fort. Interestingly, there are oral accounts in the community that say when the Europeans were leaving, when the British, so this was owned by the British, when they were leaving, they bombarded the fort to destroy it and make sure the natives don't take over the fort. So this we can confirm. Now we can also confirm that the artistic impression is slightly wrong because instead of 4 bastions, we actually have 3. from our studies. That's true. And then the other part that we can confirm then is like the mustard ball part I was telling you about, and then the fact that we found local materials at the same place that we have European materials, which means there was much more closer interaction between Europeans and then the natives in that particular setting. So the archaeology thing is kind of like, for me, it's finding hidden stories that were not there. For instance, the Volta region one, there wasn't that awareness of, let's say, the key role that maybe African families played in the slave trade. So most of us, and especially not in the Volta region, I wasn't expecting that. So we are always looking at the slave trade as form of something that was imposed on us, right? But one of the things I found as we've kept on working on this site is that in certain cases, we actually had agency. We knew what we were doing. We thought, okay, if we participate in this, it will make us rich and make us powerful. Because if you participate in this, you get more money, you buy more guns, you get to seize more people, and then once you seize more people, you get more guns, and then and of course that makes you how do you call it, powerful in your domain. So those kind of hidden stories, I think are good for us to know, because I think that the stories, the history of that era is still mostly from the Eurocentric point of view, and we need to uncover those stories for ourselves together. There's one probably other story I should share before I this chapter. So last year we went Benin for a survey. Now this site had been studied by a couple of universities from the US, and they had gone into the site in, I think, 2022. And they were looking at the site as a normal African village that had changed over time. So they wanted to see how the community had changed with interaction with Europeans. So how was the community before Europeans, and then when the Europeans came, what was the interaction, and then post-European occupation, what happened? Okay. So that was the focus of the survey. Now so archaeologists had taken some excavation pits around. They had found materials, but then all the materials were like, okay, if you find a huge pit, we are looking at a place where people dug up the soil to maybe build community. Because of course in Africa we build with the local materials, mud, all that. Good. But then the places that had these huge pits, they didn't find a lot of artifacts, so they were kind of perplexed. Why is it that the pits that we actually think should have a lot of artifacts, but if that's where the people live, we are not finding any material? So that's where we actually came. That okay, let's run a survey across the whole site and see whether we can find something that they have missed, right? So we did a whole survey, a magnetic survey, which is essentially working over the whole place with some form of magnetic instrument, which then tells you the magnetic properties for the whole place, right? And once we did that, the interesting thing is where the pits were, we found really, really high magnetic anomalies, which means the magnetic intensity there was very high. Now, if the magnetic intensity there is very high, it could be because the people who stay there had been working with some metallic materials, or they were using that. The second option would be that there was some geological material below the surface that they were looking for, which was giving us that. So I don't know whether I can make that clear. So it's either the humans who had lived there, like the natives in Benin, had left some material there in terms which was causing the magnetic anomaly, or there was a magnetic anomaly that actually brought them to that site. So those are the two competing kind of hypotheses. For the American universities, they were more focused on the fact that it's the humans that had lived there that had created anomalies. But once we got there, we saw these pits, and we immediately said we don't think these pits could be places that they just dug for building, because they looked like the Galamsey sites we have in Ghana. They were huge, even though they were not modern size. You could see that the pits were huge. So immediately for us, we thought, no, then we should be looking for something much deeper. And when we did the magnetic survey, we actually found that there was this high magnetic intensity was probably related to iron iron deposits below the ground, right? And now, once we found the iron deposits, the question was the American scientists were saying, okay, but even if you find iron deposits, we've not found tunnels that seem to connect to mines, or we've not found any kilns or heads where they could have worked the iron. So I said, okay, let's go back to the geophysics again. So for basic physics, if you have clay or any material that you heat up for a long time, the magnetic properties change. So that will also pop up on any magnetic survey. So we located some of those ones and said, okay, go and look for those points and then excavate. Once they started excavating, they actually found altered clay that you could see clearly had been altered by fire, because they were really hardened clay. That could only happen usually when you heat clay through some process. So we found a kiln. And then they went back this year to look for some of the other anomalies that we had detected. And surprisingly enough, they were able to find tunnels on these huge excavated sites. So with even steps, like they had steps in the tunnel. So as they excavated, they could find steps that showed tunnels connecting one place to the other. So now look at this. If it were just Americans going on this site, their focus would have been on, they are just looking at a typical African village. What did they do? They lived, they went away, and then the next thing is the Europeans came, and of course they can see European occupation when they find anything like pottery from Europe, smoking pipes. So once they see that, the story ends. It's like, oh yeah, they leave, Europeans came, they interacted. That's the end of the story. Now with the geophysics, we brought another angle to that story. So this is like a whole mining community that was working iron, which is about 1,000 years ago, according to their dating. There's a whole kind of like an industrial complex in that place that was mining iron, working the iron, and possibly what else they were doing with the iron would be open for more research. Yes, but those are the kind of things I think that's one of the reasons I think we should do more of this, so that we can actually find those stories from our perspective, because then we will be interested. I was interested in finding out if these are your forefathers, how sophisticated were they living 1,000 years ago, if they were mining iron ore and working the iron and moving around with that. Imagine how that. Yeah, so
The more mine.
I'm always excited about that part.
Yes, I'm gonna bring tea. But is there still iron under this ground discovery place that you found?
Yeah, there's still iron. The magnetic anomaly is clear, so I'm sure there's in that area as well. They have some mines not too close to the site we're working, but they still have iron in there. So
Great, interesting. So I have another question from Sarah. I would like to know if you work with the archaeology department or history department of the university so that they can update their knowledge and maybe even what they teach to students from your research findings. I think this is very important question.
yeah, so for each of the surveys we've done, I think the Volta region one, because you need a permit from the Ghana Museums and Monuments Board, and then we had some people from the University of Ghana's Archaeology and Heritage Studies Department. Last year at Otiam in the Central Region, we even had somebody from the Museums and Monuments Board on site. So the workflow is that once you get a permit from them, you do your research, whatever you find actually goes to the Museums and Monuments Board. So the University of Ghana works on archiving, documenting, recording, and then once they are done with that, it goes to the Museums and Monuments Board for safekeeping. So one of the things we are planning to do is to have an exhibition of the things we found so far. Hopefully, I can get that organized by December or January. It's still part of the planning, but yes.
Great.
So we do work with them closely.
Okay, because I think that if the story is changing, it's important that the correct or it is updated, right? So that we're learning the right things. But it's interesting you talked about working on the exhibition because as you were sharing some of these very fascinating stories, I was thinking, okay, if we're not having this conversation, this is the first I'm hearing of this, well, maybe the second, but this is the first I'm hearing of it with this much detail. And in the same vein that perhaps it's my bias, Archaeology is perhaps not as prominent as some of the other sciences that are showcased, right? So how do we support the storytelling or the capacity building or the community engagements around the archaeology, the importance of archaeology, some of the significant findings that through the work of geophysicists and archaeologists have been able to contribute to knowledge and history, what's in the museums that have most recently been discovered through some of the work that geophysicists and archaeologists have been doing. I think it will be a really interesting storytelling or exhibition piece. And so, yeah, interesting concept to explore. Yes. So I have another question around the excavation, because when you share the story from the Volta region, you have evidence that there are remnants at this compound, but it's you've left it. And you said it's a story for another day. But I'm curious, how much time and effort, or what are the logistics to actually start excavating?
Yes. Yeah. So the challenge with that is, the number one challenge is funding.
Okay.
Getting on site and doing, even the geophysics is usually expensive because you are going to take a team going to a site. You are going to be there for a week or two, which means the team is consuming food and resources every day, and then moving equipment in and out, that kind of. So we work when we get funding. So for instance, the 2022 one was funded by the SCG, and because they were funding, the SCG is the Society of Exploration Geophysics in the US. So they were funding training for students on geophysics. It's just that for me, I added the twist of that we can use this to do research in archaeology. Yes, in archaeology. So we didn't have funding to cover the archaeology component for that, so we couldn't do that. So, for instance, the one I was talking about in Otiami in the central region, then we covered the whole chain. So we're able to go do reconnaissance, identify the site, have drone surveys, then focus on doing the geophysics, and then we followed up with the archaeology on the spot. So we're able to then excavate materials that we can then, those are the ones we want to use for exhibition. But I think the funding is critical. Another challenge sometimes is working with the Museums and Monuments Board. If you need a permit, you need to go on site. Sometimes there are issues with that. But so far, I'll say they've been quite helpful doing that with the kind of work we are doing. So that's good. But mostly it's funding. It just takes a lot of money to do that. Put the survey together, excavate and get the materials, and then even with all that, the community engagement is another part. So even if you are, in Ghana, if you go to any site to work, it means you need to. Yeah, I can tell you an interesting story. I think when Volta region, and we wanted to access a sacred forest, right? So a sacred forest for because then there was this story around the forest being it was a sacred forest because it was a sanctuary for escaped slaves, and then the community had decided to turn it into a sacred forest. So he had oral accounts of slaves escaping and hiding in the forest, and then none of the slave traders could get to them because of the spirituality of the place. So there's even a story of one of the slaves turning into a statue, a rock, in the forest. So over the past 200 years, you can see the community growing around the forest, but the forest is intact. So we had discussed with the chief, the king, and then he had decided, okay, I want to make this part of a heritage kind of site that people can come. So we should do the survey and see if we can find some interesting artifacts. There's already actually a chain on the surface, like a huge, like slave chain that is in the forest. Very huge one actually, and this is so you already have the inclination that there'll be a lot of materials there. Now we get to the community. We had done the initial discussions. Chief was in agreement. We got to him. He agreed. He spoke to the others and said, "Oh, this is what the guys are coming to do." And then they said, "Okay, you need to buy a white ram." So that was not part of my calculation when we were going there. You need to buy a white ram, buy some alcohol, different categories of alcohol, and then we would do the rituals and everything. And this was, we had gotten there on a Monday afternoon. And then, okay, they did all that, and then they finished and said that God said you cannot enter the forest. So you have to wait for, that was a Monday, you have to wait till the next Sunday for the gods to give you permission. And I said, what? I have a whole team sitting here in hotels with our car, with everything. They can't be eating for a whole week whilst we wait
It's
for
for
the
the gods
gods
of the land.
to give
Yes.
us to give us permission. All right, so they said, okay, then you need to buy a few more stuff. We go back and ask the gods if they would agree. So we bought a few more stuff. Uh, they asked the gods, and they said, okay, they think they are in agreement. We can go now. Then the guys who were supposed to help us cut a path through the forest so that we could do the surveys were like, even if the gods agree, we are not sure this works because we are afraid once you guys leave, the gods will strike us. They won't strike you; they will strike us. Okay, so this was all right. So what do we do now? I was said, well, if you pay us a higher amount of money,
They'll turn
the gods may not. So, so we said, okay, really, but if you pay a lot more money, how does that affect the gods agreeing? You know. And then we had this whole back and forth, back and forth. Finally, we couldn't actually go into the forest because then at the end of the day, even apart from that, some members of the community then thought were actually coming to the chief had actually sold the land.
Mm.
So even with all this, after we had done all this community engagement, some people in the community thought we had sold the land because we were wearing all this, we were safety conscious, we were wearing all this our bright vests, and we are going on the field, which is supposed to do, but then to them it looked like, oh, the forest has been sold, the forest that we've kept for years. So I think after a week of being there, was the BNI that got to us. Fortunately, when we got to the community, and I always emphasize this, we do a lot of community engagement, chiefs, security officials, just to be sure you're on the right path. So the BNI then contacted us and told us, okay, this is a bit of a dicey issue. We've heard rumors that they picked up intelligence that some of the people are angry and they may be targeting you. So we don't think it's wise to go to that place. So then we had to change the whole plan and go look for a new site. So this is just an aspect of the kind of stuff you encounter. And I've seen a lot of that because some of these things are sensitive.
Yeah.
Like the family I was talking about. To say you found materials that show that this family was actually they were prominent players in the slave trade. How does it change the dynamics of the community? Because there are some families who also know they descended from slaves. Because when the British abolished the slave trade, some of the slaves were just allowed to go. So some were from Mars, but then they settled there. And the communities actually know this family. So if you then say, okay, this family was the major player, they may have brought your people here. How does that change the dynamics of the community today? So those are some of I think those are more of the nuanced issues and much more difficult to negotiate rather than the hardcore issues. That's for the funding issue. I think every researcher in Ghana will say funding is a problem.
Funding. Yeah, we're all looking for money, aren't we? Really
Yeah.
interesting stuff. Really interesting. So, and I've certainly learned a lot more than I did know about archaeology and geophysics before this conversation this evening. Let's we haven't touched on the AI so much. I am conscious of time. Where does AI come in?
Okay, so my PhD was in applying AI, machine learning. Now everything is machine learning to geophysics for interpreting oil and gas reservoirs, how to find oil and gas reservoirs. So for this side, the vision I have is not even the slave part. Let me just go in a little bit of detail. Now, and I've mentioned this because when we build in Africa, we build with local materials, clay or mud in your particular situation. One of the reasons, for instance, I'm sure you'd say you don't know a lot about archaeology in Africa is that once a community leaves the site or where they were, everything goes back into the ground. Now, how do you distinguish between the clay that was dug up at a particular place to build and the clay that was actually there from the beginning? That is difficult. We don't have the same problem with Europeans European history because they built with stone. The Greeks built with stone, the Romans built with stone. So you can find, if you go, the Colosseum is right there. Even the old roads that they did in Roman times, you can still find them because they had stones that they had, which is different from Africa. So the focus in Africa would be to be able to distinguish between clay that we use to build and then the clay that never left the ground. Once we do that, my thinking is that then we'll discover a lot more communities and a lot more of our history that has been hidden as well. Right. So it means that we have to do a systematic survey of different sites. For instance, we need to go to the north. We need to profile the clay materials and see the difference between standing maybe buildings and the clay that is already in there. And then find the geophysical signatures like the magnetic properties, the electrical properties, and any other property that we can find. Now, so the overall scheme of things is that once we can find those signatures across the country or across West Africa, then we can use AI to be able to identify those features much more easily when we do a survey. And that will bring everything together. And it means we can now scan the whole continent and tell you where we think people would have lived and how they lived, different from where else we think there was no habitation at all. So that's like the big dream, the vision. Yes. So we are working on that. So now we are just working on the sites to collect as much data as possible. And for AI, you need a lot of data, which can then be introduced to the algorithms for your algorithms to be able to distinguish between what is there and what is not. And once we have that, my intention is that we should be able to predict the sites that are most likely inhabited across the continent, and then we can be able to identify a lot.
Well, I haven't even interjected this whole time because of the fascination of the storytelling, and that has turned out to be. But this is Geeks by the Fireside, hosted by GH Scientific, and our guest this evening is Cyril. He is a geophysicist, an archaeologist, and we've just heard how he's applying machine learning, not AI, machine learning to study, I suppose, the location or where clay has come from in terms of were you actually in the ground or was it from breaking down buildings, if I'm getting that quite accurately. Great.
Yeah,
So if we move away from the fascinating, not that the other things are not fascinating, science that you've been researching on, I know you have, is it an NGO? Is it a side gig? Is it a hobby? Is it a passion called Afro Sci Tech, correct? And I know it's not very active. I can totally relate because
yeah.
24 hours in a day, and we all try to find the prices.
Yeah.
So, can you tell us a little bit more about less heavy stuff that you do aligned with your interest in, you shared some of the training you did for, students in the past, so you must have an interest in community engagement, etc. So tell us a little bit more about your other ventures.
So that's that's all of the above. Passion is an NGO registered, of course, then, but it's a hobby, a side gig, and let's put all of those together. Yeah. But then I think that started in 2020. I think during COVID, I was in China at that time actually during COVID. So uh, we woke up one day and they just told all of us stay at home, don't get out of the house. So I didn't have access to my workstation where I usually do my stuff. So I said, okay, then since I've been interested in SciComm for a long time, let me start something. So I think the first stories we did were more on a lot of people don't know there are a lot of African students in China. I think from the 2010s coming, we had a really large population of Africans doing PhDs and graduate studies and undergrad studies in China. So, and this large community was doing some great work, but because usually the focus is on Western countries where people go for graduate studies, the stories were not being covered. So we just decided to start covering some of those stories, presenting their research work, the achievements they were, the kind of achievements they were getting and all that. So we did that over some time before I came back to Ghana. And then in Ghana, we expanded that to do a little bit more of SciComm, share stories around science stuff. And then do some training, of course. We've been doing training. Tom has been helpful in some of our training materials, getting some of our students interested in SciComm as well. As you know, the space in Ghana it's limited in terms of SciComm. Um, I think I watched an interview yesterday and somebody was saying every blogger in Ghana is an entertainment blogger, right? So everybody blogs about entertainment. Meanwhile, um, we need science to grow. Uh, that's how can we come up with. You hear stories like a passport, a Dutch passport is far better than a PhD because we have a large population that thinks science is divorced from their regular way of life. They don't see the connection. And I think it means for scientists, especially, we need to do a lot more work in sharing the research we are doing. Um, Most times, these things they are affecting people, but they just don't know. The recent one is that that there's been a debate about the HPV vaccine, and a lot of people are up in arms. And most of the people, when you hear them, it's just that they don't understand how it works. It's not that they may not be against it totally. It's just that when they hear something on CNN and Americans say they don't like vaccines, then they should also react and say they don't like vaccines, right? But they, that and that I think means that a lot of us scientists need to do more science communication, and that's what Afro Science wants to do. So our tagline is actually amplifying the voices of African scientists. Um, if you can get stories of science, what you are doing in the field, how it impacts people, so that people can make that connection. Your science affects them in their daily life, then the visibility would first of all encourage more people to enter science, which I think we need clearly. Most people think that we have too many PhDs. We don't have. I'm not sure we even register on the number. Like if you compare with the developed countries, we are not there at all. And there's a direct correlation with the number of researchers you have and your development. We are not there, so we need to do more of that. The second thing, of course, is to make science more accessible. And then the third thing, of course, which I strongly believe in, is that even some of our own things we do that we've not studied could actually be helpful in enlarging the world of science globally. Um, I always use this as an example. The process of getting palm wine is such a complicated process. Just if you've ever watched somebody tap palm wine, the process is complicated. And I'm always fascinated that somewhere along the line, somebody either experimented and thought this doesn't work, so let's go do this, let's do that, and then finally you have a process where when you take palm wine now, it's really sweet and you enjoy it. But that is science in itself. Either someone or a whole community or a generation of people would have experimented with this, tried something, it didn't work, then try something else. And that is science. So if you can make all these things clear to everybody that science is not some Western concept that somebody is forcing on us, but it's all around us. We practice it without knowing in most cases. So it's just a way of living, and if we apply it to our lives, we'll probably find our way into a more developed status in future. That's what Afro Science stands for. So if anybody is interested in volunteering, helping with that, or it chimes with your vision and strategy as well, yeah, we are always ready to help. Of course, we do a lot of stuff with GH Scientific as well. For instance, the Sci-Fest in Kumasi that we did this year and last year as well. So yeah.
Great, excellent. Thanks for that. So at this point, I'm going to hand over to Dr. Thomas Tego to round this up. But his last comment was for your palm wine, there was no experiment, it came from the gods. So over to
Yeah,
you.
that's
Thank you so much for your time this evening, Cyril. Tom will take over and just tell us what to expect next. And for everyone
thank you so much for having me.
who's live today, hopefully you've been fascinated as much as I have been. I certainly learned a lot more, and now I'm curious and I'm going to follow up with you because we need that exhibition, whatever form the storytelling is going to.
Yeah, the pressure will help.
Yes, yes, it must happen.
Okay, so there's a comment in here from Isaac. Okay, so he's asking, in archaeology, he's guessing there could be applications in crime investigations. Are there any instances you can highlight briefly in terms of using geophysics techniques for sort of like crime scene investigations?
Oh yeah, that's a very good question because we are actually running an experiment right now on KNUST campus where we've buried pigs over the past 3 months. So we bought pigs, huge ones, about 90 kilograms. We dug up to 1.5 meters. We buried them, and we've been monitoring the using our equipment. We're monitoring over the past 3 months, like I said. So we are trying to find out how long we can keep on seeing the signals from where the buried pigs are. Which means if we can do that over time, we could use the same to find buried bodies. That's actually the idea. People who clandestinely bury bodies after a homicide or something.
That's
Very
yeah,
almost
that's
question.
interesting
Yeah.
because then I guess that's now you sort of like creating what it will look like, right? Because then considering soil conditions, humidity, temperatures, decay rates may be
Yeah.
very different from what's in established literature. So you doing this, wow, that's
Yeah.
nice. That's
Because
nice. Please,
some of that work has been done in the temperate zones, but the point is
yeah.
the tropics are very different from the temperate zones. So you think in the temperate zones things don't decay as fast as in the tropics. So um, there's one experiment that's been running for 5 years, for instance, in the US, which is it makes sense because the place is towards the Arctic Circle. It's up there in Alaska or something. But you can't do the same in Ghana. So how long can we see the signals? And even if you can see the signals, in what way would they be? Because the source will be different. So that's like a simulated burial for a clandestine, maybe a criminal doing some kind of clandestine
Yeah.
burial, and then we are monitoring to see how it works.
Wow, that's interesting. You do all this interesting stuff in your little cave, Mr. Connor. Thank you so much for sharing with us. So for everyone else, thank you for joining us this evening. Tonight we've been with Dr. Cyril Boateng, who shared his work with us in terms of geophysics, in terms of archaeology, and now he's even doing CSI, a man of multiple hats.
Okay.
Thank you all very much.